Here we'll use cross products to solve a real-life word problem involving the gears on a bike. We are told that the bicycle's gear ratio is the number of teeth on the big gear, and then a colon, and then the number of teeth on a small gear. We are also given that this bicycle has a gear ratio of 6:1. This means that for every 6 teeth on the big gear, we will have 1 tooth on the small gear. Notice the picture I have on the right has the small gear on the left side and a big gear on the right side. Based on the gear ratio, we can say that for every 1 tooth on the little gear, we'll have 6 teeth on the big gear. First, I'll write down the gear ratio. For our small gear, we'll have 1, and for the big gear, we'll have 6. I'll put a colon in the middle. We're then told after the gear ratio that the small gear has 14 teeth. So I'll make a little marker for teeth, and I'll write that the small gear has 14 of them. We are then asked how many teeth are on the big gear. That is an unknown. So for my big gear, I'll write X. For my small gear, I'll write 14 and put a colon in between. Now I have 2 ratios. The gear ratio that the problem gave me, which was 6 big and 1 small. We can write that the other way around and say 1:6 if we're writing small first and big second. It doesn't matter what order we write it in, as long as we keep it consistent, that the small is still 1 and the big is still 6. I wrote it as 1:6 to show that the 1 goes with the small, which is on the left side of the picture, and the 6 goes with the big one, which is on the right side of the picture. This means that 6 must stay with the big one, and the 1 must stay with the small one. But to make it match up with the picture, or for whatever reason you like, you can always invert it. But the important thing here is that I notice that I have 2 ratios. Because I have 2 ratios, I can do a cross product. To start my cross product, I'm going to write 2 division bars with an equals in between. My first ratio is 1 small to 6 big. I'm going to write my smalls on top and my bigs on the bottom. 1 will go next to small and 6 will go next to big. Then my other ratio is 14 small to X big. I know that my number of small was 14, but my big ones I don't know. I'm going to call that X. Now I'll do my cross product by multiplying the 1 on top of the first fraction times the X on the bottom of the second fraction. I'm now drawing a line to connect them, and I'm going to write that that's 1x. Then I'll take the bottom of my first fraction, that's 6, times 14 on the other fraction. That's going to give me 6 times 14. I'll now place the equal sign in between and rewrite this. If you see 1x, you don't have to write the 1 if you don't want to, because the 1 will not affect your answer if it's multiplied by x. It's okay just to say x here, but if you want to leave the 1 there, it won't hurt anything. We'll have x equals 6 times 14. We can now go to the calculator and multiply 6 times 14 to give us our x. We'll take 6, press times, and then press 14. When we hit enter, we get 84. Therefore, our x will equal 84. This means that if we have 14 small teeth, we'll have 84 big teeth. So if the small gear had 14 teeth, the big gear would have to have 84 teeth if we wanted a gear ratio of 6:1. Here we'll do another real-world example involving medicine. The question says to imagine you're a nurse who needs to administer 130 milligrams of medicine to a patient. The medicine is dispensed in liquid form with 20 milligrams of medicine per milliliter. How many milliliters will you need to use? I placed these pictures on the right side of the frame to show you the difference between milligrams and milliliters. For those of you who haven't taken a science class in a while, I've given you a picture that has powdered aspirin, just to give you an example. 1 milligram would be about one tiny little grain of this aspirin. I'm going to label this picture with mg for milligrams. Now, with a lot of medicines, we don't take them straight in powdered form. Oftentimes for medicines, we'll dissolve that medicine in a syrup that looks more like the picture on the right. So I'm going to make a note that milliliters represents the syrup it's dissolved in. That spoonful of syrup that I have in the picture represents maybe about 5 milliliters, give or take. However, in the question, we were told that this liquid form of the medicine has 20 milligrams of medicine for every milliliter. Therefore, I'm going to write that the way it's dispensed is 20 milligrams to 1 milliliter. For this reason, I'm writing a 20 under the milligrams, then putting a colon, and then putting 1 milliliter. You may notice that in the problem there was no number next to milliliters. If there's no number next to milliliters, we can put the invisible 1. I'll even write that in the question now. Please note that mathematicians will make a lot of use of the invisible 1. We'll have to remember to write it when necessary. Now, back in line 1 of the question, we were told that we need to administer 130 milligrams of medicine to the patient. Therefore, I'm going to write down that we are to administer that amount. I'm going to make sure to place the 130 underneath milligrams. Imagine that as the number of tiny little grains of medicine that we would have to give. However, the last part of the question says, how many ml or milliliters will I need to use? That is an unknown because it asks how many. Therefore, I'll put an X next to the milliliters that go with that, and put a colon in between. Therefore, notice again that I am comparing two ratios. Because I'm comparing two ratios, I can use a cross product. I can start by writing my two division bars with an equal sign in between, and I will place my milligrams on top and my milliliters on the bottom. My first ratio is 20 milligrams to 1 milliliter, so I'll place 20 on top and 1 on bottom. My second ratio is 130 milligrams to X milliliters because I don't know how many milliliters to use. We're going to say 130 on top and X on the bottom. Now I have a cross product, and we can try to solve that with our algebra on the next page. Here on the next page, we'll do our cross product. We'll take 20 on the top of the first fraction times X on the bottom of the other fraction, and we'll get 20 times X, or if you prefer, 20x. Then we place the equal sign, and we multiply 1 on the bottom of the first fraction times 130 on the top of the other fraction. If we take 130 times 1, we will still get 130 because the 1 will not affect our answer. Now let's think about how to get the x by itself. Since I have 20 times x, I can take the opposite of times, and that's divide. But when I divide, I must make sure to divide by the number next to x. So I'll say divide by 20 on the left and divide by 20 on the right. If I take 20 over 20, that will cancel out. I can now just write x, or 1x if you prefer to write the invisible 1. Then on the right, I'll have 130 over 20. I can go to the calculator and punch that in. We'll enter 130, division sign 20. When we press enter, we'll get 6.5. So I'll say x equals 6.5, and remembering that what we needed was milliliters. Therefore, to administer 130 milligrams, I would need 6.5 milliliters. If you work in the medical field, you'll do an awful lot of these calculations. Now, Most nurses have their own methods of doing these that might be a little bit different from what you see here. But if your plan is to go anywhere in the medical field, practice this now so you'll understand what you end up doing later.